Hi there guys, welcome to another video, and in this video I'll be talking about the latest Anthropic Cloud 3 release, the latest state-of-the-art models, and we also be using it within a RAG system, just same pipeline, same steps, and just using Cloud 3 to actually act as that base model, the LLM for our RAG system. So let's cover what has just happened this week. So this came out 3 days ago. We have Anthropic, one of the leading companies within the AI space at the moment, releasing a bunch of models referred to as the Cloud free model family. We have three models within the Cloud free family. We have the Haiku, we have Sonnet, we have Opus, and these models were basically created with a very good balance of intelligence, speed, and cost, with the most intelligent being Opus. The key thing that everyone is talking about is the fact that these new class models actually have top scoring percentage on a lot of cognitive tasks and a lot of benchmarks. And they are on par with some of the latest state of the art models that have come out from OpenAI and Google. What's even more interesting is the particular point of cloud being some AGI, AGI in quotes, by the way. And this is because it was able to detect the fact that it was being tested on the test called the needle in the haystack evaluation. And this is when you have a large corpus of text and you have a very unrelated information within a text, and you're testing the language model or the model to actually retrieve that specific information. Not only was Cloud 3 Opus able to do this, it was also able to detect in some of the cases, not all, but in some, that it was actually being tested, which I would have to give it its props. It's quite interesting that it's able to do this. But is this signs of AGI? That is a question that I will not be answering in this video. But overall, it's an impressive model. I've used it, and I have to say, I do like and enjoy its reasoning capabilities in comparison to other models out there. So what are we going to be showing in this video? A very simple RAG system that uses MongoDB as a vector database and uses the Cloud 3 model, specifically Opus. The stack I'll be using here is we're going to be implementing in Python, and we'll be using Anthropic as the LLM provider, but also using OpenAI as the embedded model provider, and MongoDB as both as the vector and operational database. And I'm going to be presenting this notebook, but as usual, most of the videos I do put up have an accompanying article that you can read in your time. And I take you through the same steps to create this RAG system in this article. And I have some more information here, the key information about the latest release from Anthropic that you can quickly take away. I'll put the link to this video in the comments below. And also we have this notebook in the GenAI Showcase repository that has all the code. And with one click of a button, you can get this as well. And if you could also just star this and fork it, because we're going to be updating this repository with more demos, more use cases of generative AI. The data set we're going to be using today is a data set that's a subset of the Hacker Noon data set I was trending a few weeks back from today. And it just contains several data points of tech news, essentially. And for this RAG system I'm building, it's sort of like it's a chat bot that is acting as a tech analyst within an investment fund. So that I'll be showing you the prompt later on. But this data set has over 1 million rows. And the difference between a data set and the original data set from Hacker News is that this has the embedding of the description, which allows you to go straight into any sort of practical demos you want to build without doing the embeddings yourself. So that's 1 million embeddings, with over 1 million embeddings within this data set. So let's get into the code now. To start off, we're going to install PyMongo, datasets, pandas, and Anthropic and OpenAI. We know, most folks will know what these help us do, but very quickly, PyMongo gives us access to a bunch of methods and functions that allows us to connect to our MongoDB database and conduct a bunch of methods such as adding data and running queries. If this is a library from Hugging Face, allows us to retrieve various data sets from the Hugging Face library. Pandas gives us the ability to create data structure that are very good for analysis and processing data. Anthropic and OpenAI are going to be the model providers. The first step we're going to take is to load our data within our environment. So we're going to create this function called download and combine our Parquet file. The original data set, like the tech news data set, is in different Parquet file. They're quite massive. And we're just going to be loading subsets of this file. You have your Hugging Face token, which you can get from your settings page on Hugging Face. And we're looping through an array of Parquet files and making a request to it and downloading the content of the Parquet file into our development environment. So this is the array of the Parquet file we're going to be using. So this is a subset of the original data set that contains a 1 million records. So each Parquet file contains around 50,000 data points. Around 50,000, maybe 40,000 in some cases. But so I'm only loading just a subset of the original data set. So we pass it into this Python list each, and you can extend this, by the way, and I've kept a link to where you could get the full data set as well. But for this demo, it's best to use just one if you don't have a large database on MongoDB with a database of large storage capacity. Just use one of this. This will contain around 50,000, which should be enough. And you shouldn't reach the limit if you're using the free tier cluster on MongoDB. But if you have a database of large storage capacity, you can load more of these files. We call the function and we're passing our Parquet files and our Hugging Face token, which you can grab from the Hugging Face platform on your settings page, I believe. And what we're going to do is combine all the Parquet files into a data frame. And we're going to do some data cleaning here. One thing I'm doing here is I'm removing the ID column, which removes the ID attributes from each data point because we don't need that. I'm also converting the embedding data points from, I believe, what is a NumPy array to a Python list, just so the data ingestion goes smoothly. And this is what the data looks like. It's just going to be the company name. We have the URL of the company, and we have the name of the company, the description, and the embedding. One thing is we're only going to be using the embedding and doing a vector search similarity on the embedding. But for those of you that want to extend this, you can actually make this system go into the web and collect more information from this URL and actually use that within the embedding as well, or use that for more information in downstream processes. So which creates another dimension to the use case that we're developing here. Let's go into the creation of our database and collection. If you watch my previous videos, this is going to be trivial, but let me go through the steps very quickly. Once you go into your MongoDB Atlas, you land on the overview page. And for those that don't have a cluster, I will show you how you can create a database cluster. Click on database, and if you just click on create, you can have a free cluster. This will allow you to have a free database that you can actually play with, which you have 512 megabytes of storage. You shouldn't be loading the entire data set if you don't have a better storage capacity for your cluster. Once you're done, most of the pre-selected options are quite good, but you can change the cloud provider and the region that you want your server to sit on. And then you just create your cluster. And it's as simple as that. And you'll be able to create a database without any cost. If you do want more storage capacity, you can go into a dedicated cluster and you will get more storage capacity. 40 gigabyte is more than enough to hold the entire data set. So We've already created a cluster. And once your cluster is created, you can grab the URI, which is the unique resource identifier that will allow you to connect to your database. Once you get into the overview page, you'll be able to go into your cluster. So if you click on the database and you can see the cluster you've created here, and you can browse the collection. To create a database, you just click the create the database button and enter your database name and the collection name. So I think the database name that I use for this tutorial is called Tech News, and the collection name is quite long. I can't remember. But once you're done with that process, what you're going to see is, yeah, it was Tech News and the database, the collection name is HackerNoon. And once you've created that, the next step is quite crucial because you have to create your vector search index. So I've already loaded data, but your one, if you're just doing this tutorial for the first time, will be empty. So if you go into search indexes and you click on the create search index button, and Atlas vector search is what we need to create. You click on the JSON editor option and click next. That will give you this interface for you to create your vector search index. Navigate to the database that we're going to use and select the actual collection that we're going to be creating the index. We're going to give our index our name. Call it vector index is what I use as the name in this tutorial when we're building up the queries. Next, we're going to fill out this information. This is the JSON definition of our vector search index. We have the type, which is fine, it's vector. The field name is going to be embedded. And the dimension. So the embeddings we're using were created with the text generation 3 small model with the dimension 256 from OpenAI. And we can use a cosine similarity function. So here we go. To understand what each of this field actually mean, you can just hover on each of the fields and you get a pop-up box giving you a description. And yeah, so once you're done with this definition, you can just click next. I've already created this vector search index. And those are all the steps you need to create. Remember to select the right database and the right collection and name and give your index an appropriate name. Once we've done all that step, we will actually be able to connect to our database. So we're going to use a very standard PyMongo function and method that gives us a connection to the database. We're going to create a Mongo client using PyMongo. And from this client, we get access to our database by referencing the name and the collection by referencing the name as well. So a Mongo client, and we reference the database name, which gives us an object that allows us to reference the collection. And we have a collection object over here. So next, I already have a bunch of data that we saw within a database. And this function, this method allows me to just clean up the data and just start at fresh. And we had about 200,000 data points that we just cleared out. You can comment this out if you're just doing this for the first time. This won't error out anyway if you don't have any data in there. We convert our data, our combined data frame into essentially JSON that we can then ingest into the collection by calling the insert many function. This will ingest all the data in batch into our MongoDB collection. And it's that simple. That is the data ingestion step. This essentially takes less than 5 seconds, if that, and which will allow you to then have access to all your data sets and all your data points within your database. Next, we're going to create this vector search function, and this function is going to conduct all our queries. It's actually going to conduct that vector search query by taking in the user text. So this is the text the user enters or the prompt we give to the chatbot we're creating here. And then we give it object representing the collection, the MongoDB collection. What we're going to do first is call a function called getEmbedding, which we're going to implement later on. And this function getEmbedding takes in the user query and converts it into a numerical representation using the OpenAI model. Once we have that query embedded, we pass it into our a vector search query, which is very simple. I will quickly explain it. We're going to be using a vector search command within MongoDB, and we're going to pass it in our vector index. This specifies what index to use. So make sure the name you specify here corresponds to the name that you've placed in the JSON definition for your Atlas search vector index. We're going to pass in that query embedding as a query vector and the path to the embedding field within each record that we'll be doing the similarity with, and that is in the embedding field. We're going to consider 150 candidates for the similarity search, but we're only going to get the top 5 results. One thing I'm also doing is excluding certain fields such as the ID and the embedding field, as I don't need this information later on, further in downstream processes. We pass each of this stage into an aggregate function that we get through the PyMongo client. And this allows us to essentially execute each stage of our query in a composable manner, essentially. And what we return is a list of the search results. And that's what this function returns. Now, that get embedding model I spoke about earlier, we're going to be using the small model from OpenAI, and we're going to be using the 256. You have to specify the 256 dimension because the embedding in the database has the same dimension 256. So this is very straightforward. This function takes in a text, converts it to an embedding, which is a numerical representation of the text, of the context and semantics within the text, and then we return the embedding. And this is the key part of this tutorial. Is we import the Anthropic library, we create an Anthropic client over here, which essentially takes in our API key, which you get from the Anthropic console on your console on the settings page. And what this gives us access to is a bunch of functions and the models that will allow us to perform the magic of the RAG system. But let's create a function called handle user query, which will format the result from the information retrieval we do with vector search and format it in a manner that is quite understandable by the Opus, essentially. So what I'm doing here is I've called it get knowledge, and we're running that vector search query, passing in the user query and passing the collection reference. And we're going to concatenate this string, which is going to represent the search result. We're going to format it and extract the key information we want from the search result, which is the title, the company name, the URL, the date published as well is quite important for our use case, and the description. Next, we're going to use that Anthropic client we created earlier to access the ability to have a back and forth conversation with the model we specify here called Opus. We're going to place in the maximum token for the output to 1024. And this is the system prompt. You're a venture capital tech analyst with access to some tech company articles and information. You use this information. You use the information you're given to provide advice. And obviously, don't take any advice that this model produces seriously. This is not financial advice, but this is just for demo purposes. Then I specify the user role, and we pass in this prompt telling the system, Opus, to answer the specific query that's been asked using the search result as additional context. Now, this function will basically format the information we've retrieved and send it over to Opus, and the function will return both the response and the search results that we used to gain the response. So the query that I've entered is essentially, give me the best tech stock to invest in and tell me why. We're passing in the query. We're also passing the collection object we created earlier, and we'll pass it into that handle user query function. And that will give us a very simple response to this query. So there's going to be a bunch of articles that have been provided to Opus, and from those articles, it's going to give us like the best tech stock to invest. And here is the response. So he's just said, I could actually zoom in here. It said, based on the information provided in the article, it's recommending Alibaba Group Holding. Well, interesting. Um, to invest in for 2023, and it gives the reasons because I've asked it to specify why, and it gives the reason very structured. I like the structured output. It gives 4 reasons. Ray Dalio, a renowned investor, has included Alibaba, and it just gives very simple reasons. I don't know how accurate these reasons are. I'm not a financial person, but also it mentions some points that allows us to it mentions some points we should take into consideration before investing, which are like some cautionary point, which is impressive to be able for it to be able to then give additional information apart from just answering the question. It goes even further to give more information um above what it's been asked us to do, which is an impressive shows an extensive reasoning capability. It goes beyond just answering the question. And then it gives us obviously a warning as if any investment is essential to conduct thorough research, consider your risk tolerance, and diversify your portfolio. I'm not a finance person, but I do think this is some a decent advice. And while Alibaba appears to be a promising tech stock for 2023, it is always wise to consult with a financial advisor before making any investment decisions. That's good advice, Opus. So we can see what it's used to generate this answer. So the first article he used was this top 10 technology stocks to buy in 2023, according to Ray Dalio. This is the results that our vector search actually returned. In terms of the similarity between the user query and what we have in our database. And these are the top 5 articles we got. You can increase this by increasing the limit of our vector search query. You can increase it from 5 to 10 to get more context for Opus. Or if you can actually go into each of these URLs, such as the company URL or the article URL, to extract more information to provide to Opus, because Opus does have that large 1 million, well, for enterprise use cases, 1 million context length, but he also has 200k context window that you can utilize. 1 million context window is not a regular, it's an expensive regular. Essentially, it still works to just do a vector search similarity just to get those certain data points that will just give you the key information you need to pass to the base model you're using for your RAG system, as opposed to passing in over 200,000 tokens every single call. It's gonna get expensive really quickly. So that is what we have for today. Just using Cloud Opus within a RAG system, very straightforward. And as usual, we have the article version of the video here. In 6 steps, we go through the process, and we also have the code for you to actually access within this repository. And you could just go straight and load this into your collab. And that's it for the video. I will see you in the next one. Let me know if there are any models or any topics you want me to cover. And we will see if we can get it done for you guys. So thank you and happy hacking.